Okay, we have everyone will get started. Last time we covered this chapter 9 stack, and we studied a little bit on Q. And today we'll continue Q, and this Q actually not a lot of things that need to be covered. And then chapter 10 is set and map. We will actually jump to chapter 11 first because chapter 11 is priority queue. Okay, we'll go to the priority queue first. And then we'll go to heap as well, and we'll go back to set and map. Okay, so that's the order. These two chapters, actually this time I will swap the order. I think chapter 11 should go before chapter 10. Okay, anyway, we are going, we'll finish this AP CSB soon, and then in February 28th, starting February 28th, we'll start to use AP review course. AP CSA review course. Okay, so remember that. And then this one, we may continue depending on how much time we have, and we may move this course to maybe Friday night. Okay, so depending how much time I have. Okay, anyway, let's continue. Last time we talked about stack, and then we talked about queue. Queue is a interface. Queue by itself has not much things to cover. Okay, very simple. But there are two kinds of queue. One is priority queue. So priority queue is in chapter 11. And then today we are going to talk about DQ. And DQ is the idea of double-ended queue. Double-ended queue means it's a queue with two ends. You can get in from here, get out from here, get in from here, get out from here. So actually, from the tail and head, either way you can push the data in and pop the data out. Okay, that's called DQ, double-ended queue. And double-ended queue, there's only one solid concrete class. The concrete class name is called array DQ. Again, this one the same as array list. Array DQ. DQ is a concept. List is a concept. DQ is another concept. DQ is a double-ended queue. It's a concept. The real thing that implement the DQ is array. So array DQ is a DQ implemented by array. Just like array list is a list implemented by array. Okay. So if you think about the insertion, deletion, push pop, any kind of performance, you have to think about this one is actually an array. Okay. Now, array DQ. Okay, we talk about DQ and array DQ. So array DQ and list performance-wise are very similar, except that array list conceptually you are actually pushing the data at any location, changing the data at any location, and you are appending things from head or back any way you can do it. DQ is double-ended queue, so I think that only operations are different. Other than that, the implementation itself, DQ, array DQ and array list actually almost the same thing. Okay, now going back to JavaScript. So JavaScript, there's only one data type. For compound data type, there's only one type. So JavaScript only has array. They don't have queue, array list, vector, linked list. They don't have anything like that. So they do have only one data type called array. And then JavaScript array, in fact, it is an array DQ. It is an array DQ, it's also an array list. It is an array used for list and also used for DQ. So JavaScript array you have all of the function that array list has. It also have all of the function that Deque has. Okay, so JavaScript array is more than just array. It's not the array that you know in C language, C++ language, or in Java language. Okay, so it's actually totally different. And Python's list in a way is also similar to array list or array Deque. So Python's list is almost the same as the JavaScript array. Okay, and in a way, JavaScript array is still more flexible than Python because JavaScript array list, JavaScript array, it allows unallocated memory to be assigned with a new number. So for example, you have 3 elements in the array, but if you write A100 and assign it with 3, JavaScript will take it, but Python won't. Okay. JavaScript array is the most flexible one. Okay, anyway, just for comparison. Okay, coming back to here, we do have this array and Deque, and then application. Okay, Q itself is very simple. Q just doing buffering, and then last time we talked about buffering has a lot of application in video streaming in operation system. Now, there is a theory in mathematical theory called queuing theory. Actually, this is one course. Okay, let's actually try to look at some course. Let's look at Stanford queuing theory. Okay. So Stanford do have a course on queuing and scheduling of processing network. I think this one is related to operation system or network. So if you study computer network or study operation system, then you will need this course. It's actually from School of Engineering. Okay. So this one is queuing, scheduling, processing network. So queuing in a way is very important. So usually the queuing is used in queuing system, and queuing system will draw a diagram that is called queue network. And queue network is actually used to simulate or emulate the dynamic system of buffering. Okay, if your system have a big buffering, you would have this kind of the arrival departure mode, and then there's a queuing node to do simulation. Okay, and then there are mathematics to talk about whatever, how much latency it will be, and then okay, there are tons of math. Anyway, we don't talk about much here. Okay, just let you know that queuing is very important, and in the operation system, this queue is very popular. Okay. But here we do not actually work on the operation system queue. That's too much. Okay, that's too much. But just that you know that queuing theory is actually very important. Sometimes it's very important in operation research. So if you do AI or optimization theory, you would actually see Q a lot. Okay, you will see Q a lot, and then you need to know about how to use Q to simulate telecommunication system, traffic, okay, and also operation system. These are a few topics that would use Q. Now let's look at Deque's use of Deque. Okay, let's look at one example from internet. Okay, in a way, array DQ, let's copy it directly. Okay, it's not very difficult, so I don't want to write the code again. So let's do this one called use DQ. Hmm? Something wrong. Okay, to use it is very similar to array list. Okay, not much difference. So here you have array DQ, here you have a DQ. So this DQ is a interface. Let's just say it's a double-ended queue. So it's a conceptual abstract data type. Okay, conceptual abstract data type. And this one is a concrete class. The array DQ is a concrete class. Okay. And then there are a lot of function. They do have add, over, remove, pull. Okay. Add is add to the tail. Over, I think it's over at the head. Okay. And then remove is actually remove from the tail. Let me see. I'm sorry. Remove is remove from the first element. Okay, pull. Okay, I'm sorry. This over and pull, if they are empty, they will return the null. Okay, some of them will not return null. That's the function you need to know about. Okay, let's just use the code they have. So you declare a DQ and then add data to it, and then see the data inside the DQ. So here you do have a DQ. Okay, use the word Q. Let's use Q. So you add first, add second, add third, and then you print out the whole queue. And then you do pull to get the first element. And then you do pick to pick on the head element. And then you do after you pull and pick. Pull, I think, will remove the data, and pick will not. Okay, so this one 3 data and then will become 2 data. Okay, anyway. This portion is not hard, so we just go over it quickly to let you know how to use DQ. DQ by itself is not really hard. So initially we have first, second, third, and then you remove the first one and you pick on the second one because the first already been pulled out, okay? And then your queue will have the second and third. Okay, anyway, that actually is not hard. Okay, that's array DQ. We have not much to talk about. It is very useful in operation system as a first in, first out data or last in, first out data, okay? But here we do, if we don't want to spend more time, okay? It's only useful when you really study the buffering system, okay? Anyway, let's go to the next chapter. So next chapter, we go to the priority queue. Priority queue is even more useful than the double-ended queue. So double-ended queue, actually, usually you have two ends. You have coming from the head or coming from the tail, and getting out from the head or getting out from the tail. You have two ends. Priority queue is different. Priority queue, in a way, is also a queue. But why is more important? That's because that it comes with priority. Okay, it comes with the priority. So now we talk about in chapter 11, we talk about this priority queue. Priority queue is actually a DQ, a queue. Priority is a queue, and priority is a concrete class. Just like array DQ, the array DQ is also a concrete class. Now, priority DQ have many different kind of implementation. You can implement it as array. You can implement it as a heap. So today we are going to talk about heap as a priority queue. Okay, this is queue. Last time we talked about it already. I don't want to waste time on this array DQ. Okay, let's actually continue. So priority queue in a way is still be a queue. So it is first in, first out. Okay, but when you actually take the data out, it is not using the time of arrival to pick the data. It actually using a priority to take the data. Okay, so this one usually actually happen in somewhere like a hospital. So let's assume that you actually go to a hospital and then there's an emergency room. Okay, so the patient arrived. So patient may have timestamp number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. Okay. But when the doctor called for service, they do not take the first one that arrived. They will check if there is any person who is life-threatening, who is in critical condition. If we don't actually save him, then we are in big trouble. So those urgent cases will be taken out. Let's assume that number 3, number 6 are urgent care, so they will be taken out first. And someone with a lower priority will wait for longer time until there's no high priority guys waiting in the line. Okay, this kind of a queue, we call it priority queue. So priority queue is a queue that each one of the data come in with the time of arrival. In addition to the time of arrival, they also come with a priority key, priority. So this kind of scene, we call it priority queue. Okay. Any questions so far?
No.
Okay, so this is actually priority queue. Now, talking about how to implement priority queue. So to implement the priority queue, we have several ways. One simple way is let's use a number of the queues. Let's use a array of queues. So let's assume that you come with a lot of data. So some data come in, you have a level one, timestamp 1, 2, 3, 4, 5, 6. And then urgent level, let's assume urgent level, you have 1 to 5. So this is level 5, level 2, level 1, level 5, level 4, level 2. Okay. So one way to implement it is that you use the array of the queue. So you use your priority. Let's assume this is 0, 1, 2, 3, 4, 5. 0 is a lower priority, 5 is a higher priority. So number 1, the first one arrived is level 5. So you put a 1 here. And then that next one is a level 2. So you put a 2 here. Third one arrive is a level 1. So you put the level 1 queue here. Then 4 is a level 5. So put it here. And this number 5 arrive is a level 4. So you put it here. And then level 6 is a level 2. So put it 6 here. Okay, so this is the kind of the priority queue. One way to implement is using array of queue. This array of queue sometimes is also called bucket. Okay, also called bucket. So bucket, you actually put your data into different buckets, and then when it comes for service, the bucket file will be used. So you will serve one first, and then serve number 4, something like that. Okay, something like that. Any questions so far?
No.
That's
No.
one way to implement it is using a multiple bucket. So let's actually look at who use this actually in operation system. Let's look at Unix. Okay, priority queues. So when you do kernel mode process scheduling in operation system, they are using priority queue. Okay, they are using priority queue. So in Unix system, each processor has a call, has a priority call from 0 to, I'm sorry, actually from -20 to +19, okay, whatever. They actually, when your process queue in the queue, waiting for the CPU to process your process. So now you actually have a lot of tasks. Each process is a task, or sometimes we call it a thread right now. Okay, sometimes it's a thread, and CPU will actually process it based on the priority call. Okay, and this kind of thing in operation system, we call it process scheduling. Okay. Okay. Anyway, this is operation system, so they will be used over there. Okay, it's called using the priority queue. Okay. So priority queue is a queue, and then it using heap. Okay, we'll talk about heap later. Okay, we'll talk about heap later. Inside the priority queue is a heap, but they do have enqueue and deque, and another function called get size. Okay, let's do it. So priority queue is a concrete class in Java, okay? I'm sorry, this one is called my priority queue, not the priority queue. Let me check the priority queue function, okay? Oh, they still call it add and remove and size. Okay, sorry. So actually not, they are not using enqueue and dequeue. So actually add is the same as enqueue, okay? And pull or remove is the same as the dequeue. Okay, so this one, let's use add. Okay, so I do not put them in order. I put them A, E, C, F, D, okay? So while okay, every time you take out a data, keep doing that until the queue is empty. Okay. So as you can see, when it come in, is A followed by E, followed by C, followed by F, followed by D. When it came out, they take A first, and then C, and then D, and then E, and then F. Actually, it's kind of like sorting. Okay, it's kind of like sorting. So priority queue can be used for sorting as well. Okay, it can also be used for sorting. Okay, and then It is the same or different from sorting because sometimes you may have A, E, C, C, F, F, D. So they may have things that come with the same code, then they will get out one by one using the time of arrival. Okay. Is that okay so far?
Yeah.
So this actually is a queue. This actually is a priority queue. But this priority queue is different from the bucket, okay? A little bit different from the bucket. The bucket actually usually can hold a bigger process because bucket let's assume the bucket you have 99, level 99, level 98. So this you may have like 1,000 people waiting over here, maybe 900 over here, okay? But this one actually, as you can see, it is almost like each level one data, okay, more like sorting. So if your system have many of similar priority, you should use a bucket, okay, you should use bucket instead of using the priority queue. So if you use the priority queue inside the Java language, then you are using the heap implementation, okay? You are using the heap implementation. Let's look at here, okay? So Java priority queue implemented by bucket. So you say here is a binary heap. It's using binary heap. It's not using bucket. Okay, let's do it in different way. So let's do priority implemented by buckets using Java language. Okay, so this one give you a bucket implementation for, okay, let's actually copy it. Okay, this one class name is called bucket priority queue. Okay, this one is a generic programming, so you have come with the data T type. Okay, inside there you use a list of queue of bucket. List of queue of bucket means that you have a linked list. So your linked list is working like this. It's a list of several levels. Each one of them is a queue by itself. So this is a list of different levels. So level, let's assume this level 99, level 98, level 96, level 97, level 96, something like that, okay? So you do have a list of queue, okay? And then first one, you need to assign number of buckets. So for example, you want to have 100 bucket, then you actually here, you need to put 100. Okay, and then you create 100 level of the bucket. And each one is a queue, so you put the data according to their bucket numbers. So when you do in queue, you put in the data, also the priority, your level of the priority, okay? When you dequeue, when you dequeue, it just take the data from the highest priority. Okay, so you actually do follow check priority coming from the highest priority to the lowest priority. Okay. To take out data from there. Okay, and there's a function called empty. So this one is a priority queue T type. Okay, that's actually, this one is only a implementation. It doesn't have the simple code. Let's write a simple code for it. Okay, so this function is called, this class is called using bucket priority queue. Okay, right here, let's set a file label. Okay, file label is 0, 1, 2, 3, 4. Okay, so then you have bpq.add. Oh, I'm sorry, enqueue. It's called enqueue. Okay, we create a few string and then enqueue all of them. Okay, so this one, alpha go to 3, beta go to 2, gamma go to 3, delta go to 2, epsilon go to 1, phi go to 3. Okay. Now we will get out one by one. Okay, let's run it. So number level 1, 2, 3, 4, 5. Okay. This one I think is actually level 1 is the highest priority. Any questions so far?
No.
So you need to remember your priority. You need to know which ones to get out first. Okay. right here, actually the smaller number is a higher priority. This kind of a heap, we call it mean heap. Okay, we'll talk about heap later. So in a way, there are two kind of the priority. One is using bucket, the other is using heap. Okay, the one that we just show you is we copy from internet. Okay, it's actually a bucket implementation of the queue. Okay, it's a bucket implementation of the queue. Now let's look at the heap implementation one. Let me open my priority queue. Okay, let me get it from our database. This is downloadable from our website. Okay. Chapter 11. There's no my priority queue. No, I'm sorry. Okay, I'm sorry. I'll look at where is this my priority queue. Okay. It seems not included right here. Okay, next one, let's directly go to heap. Okay. So first one, if we want to look at first one, we talk about bucket sorting, talk about bucket heaps. Okay. Now we look at the min heap and max heap. So heap is a binary tree. Okay, heap is a binary tree. So right here, if you have a min heap, means that the smallest number is over here. And the right side and left side are bigger than it, okay? And your data actually is, for heap, you actually will fill this one first, and then this one, and then this one, and then this one, and then this one, and then this one. Okay, that's the order of the insertion. So in a way, heap also have index. Okay, heap also has index. We will look at the implementation later. This is called min heap. Max heap, largest number on top of the binary tree. Okay, so these two smaller than it. Okay, okay, these are min heap and max heap. So right now we may focus on min heap only. Okay, because the max heap is similar to min heap. Now, if you use this heap for priority queue, what will happen? Okay, let's assume that when you do insertion, let's assume that right now you insert a 10 and it will be inserted here. If you next one you insert 11, you'll be here. Now let's actually pick a different example. Okay, let's assume that your data arrive is actually have a 5, 4, 3. No, this is no good. Let me redo it. Let's assume that the data arrival is 2, 4, 5, 1, 3. Okay, so the first one, 2 arrive. So you put it on top of the heap, so it's actually 2 right here. Next one, you see a 4. 4 is bigger, so you put it into here. Next one, you see a 5, so you put it here. Now, next one, you see a 1. So by the ordering, you put it over here for the 1. But 1 is smaller than 4, then you actually swap 1 and 4. And 1 is still smaller than 2, so 1 will be actually swapped with 2. So after 1 come in, it will be 1, 2, 4, 5. Now 3 come in, you can put it in the next location, that's actually right here. 3 less than 2, so it's okay to put it here. So eventually your heap will look like this. It's okay?
Yeah.
Kingston, is that okay?
Yep.
Now, if you want to DQ, you take data out, okay? So you do have 1, 2, 5, 4, 3. So when you take the data out, you actually would delete this one, right? And then you put your 3 to here. And 3 and 2 is out of order, so you promote 2 to there. So you put your 3 here and then promote your 2 over here. And then after that, it's okay. So your new tree become 1, 2, 1, 2, 3, 5, 4, like this. Now, next one, you take the 2 out. And then you will actually take 4. 4 is the next location to be deleted. So you take that one. And you put 4 over here. And then 3 and 4 are out of order, so you swap. So after taking out 2, you become like this. Next one, you take out 3, so you erase 3. And you put your 4 on top. I'm sorry, that's wrong. That's wrong. You should take this 5 and put it on top. And 5 and 4 are out of order, so you actually will swap. So eventually your data become 4 and 5 like this. Is that okay so far?
Yeah.
This is how the heap work, okay? This is how the heap work. So heap can be used for sorting, can be used for triathline, okay? And then you can use bucket queue, okay? There are many things. Bucket queue can be also used for bucket sorting, okay? So we do have the bucket sorting problem before, and I wish you to use a Redis to implement it, okay? But now you know bucket queue. You can also use bucket queue for bucket sorting. Bucket sorting is that, for example, you can put the letter of similar starting alphabet, so starting letter in the same bucket, and then each bucket you do sorting again. Okay. Now, if you do the whole data sorting, let's assume that you have n data and you have 5 buckets, right? You have 5 buckets. So if you have this 5 n data, you actually use 5 bucket. If you actually do normal sorting, let's assume you do selection sort. So your operation would be order of n squared, right? For the whole n number data sorting, right? But if you put them into 5 buckets, so let's assume that you have starting letter of A, B, C, D, E. You put them into 5 buckets. The bucket A sorting time is, on the average, it will be n divided by 5 square, because this one inside the bucket, you still doing the so-called selection sort. So each one of these is on the average n divided by 5 square. Okay, let's assume that. So 5 of them you do sorting, you will be 5 times n divided by 5 square, and then compare with order n square, you would see bucket sorting is 5 times faster. You use 5 bucket, then on the average, it will be 5 times faster than original sorting on the whole array. Is that okay so far?
Yeah.
It actually is, this one actually is n squared plus n, because the first one you need to put each data into buckets. So it's an order of n, but this order of n, when n grows large, if it is actually can be ignored. It's too small. Okay? Jiang, is that okay so far?
Yeah.
That's why we talk about bucket sort. And bucket sort, when we do sorting, we did not teach you that, okay? We did not teach you that. And we do have a homework on it, wish you to work on it, okay? But that's actually for your own practice. Okay, here we do analyze the complexity of the bucket sorting. And here we also talk about min heap and max heap. Let's continue. So there is one thing called array heap. So now the idea of array heap. Array heap is heap made of array. Okay, so today we are going to talk about implementing the heap using array. And heap is a data abstract concept. Okay, so heap by itself is an abstract data type. Array is a data structure. Okay, now priority queue can be implemented by array heap. So priority queue is a system component. So it's used in operation system. So priority queue implemented by abstract data type, implemented by data structure. Is that okay so far? Hello?
Yeah.
Okay, so that's the idea, okay? You need to know about what is abstract data type and what is data structure and what is system component, okay? System component means that it is a software used for system function, for example, doing process scheduling in operation system, okay? Abstract data type is a data type that you can use, but it's a concept only. They do not have concrete class to pick up, okay? They do not. Concrete class is a data structure. Data structure means that it's actually the organization of data used to implement the abstract data type. Okay, these are some concepts you need to know. Later, we will show you the user code problem, MOOC 2 and transform. Okay, that's actually later work. Now let's focus on min heap. This I think I repeated. Okay, this one we talk about heap and heap sort. Okay. So now we talk about array heap. Array heap is a heap implemented by array. Okay. So array is linear. Array in a way you are a data with index. Okay. So now let's look at it. So right here, this 0, that's the string is actually right here. 1 and 2, these two elements, let's put it right here. It's actually 0, 1, 2. 3, 4, 5, 6, 3, 4, 5, 6. Assertion is actually 3, 4, 5, 6. So level 1 is only one element, it's a 2 to the power 0. Okay. Level 2, there are 2 elements, is 2 to the power 1 element. Level 3, there are 2 to the power 2 element. So level n is 2 to the power n minus 1 element in that level. Is that okay so far?
Yeah.
Okay. So it is an array, it's also a heap. So now for first data array, let's assume that you actually come with, okay, let's do this one. 2, 4, 5, 1, 3. Okay, so when 2 arrive, 2 will be put into the 0 location. So it's right here. 4 arrive, 4 will be put over here in the index 1 location. And then there are no out of order, so it's okay. This one 5 arrive, 5 is put over here. It's in here, array location. Now 1 arrive, 1 put over here. So 1 put over here, but they are out of order. So we will change these two. To 1 and 4. Next one, you will actually see 1 and 2, so these 2 will swap again. Okay? This is insertion. So next data come in, where should we put the data? This one is 3 come in. So when 3 come in, you put into the next data here. So in a way, array heap, you are also using I equals 0, I less than n approach to put the data in. Is that okay? Hello?
Yeah.
Yeah.
So in a way, you insert the data into the array heap. It's still using I equals 0, I equals 1, I equals 2, I equals 3, I equals 4. It still follow the index order. It's still using the insertion array. So this kind of thing is not really wasting time, except that you do have promotion and demotion activity you need to know. Okay? You do have promotion and demotion activity that you need to look at. Okay, let's actually draw the diagram one more time. So right here, you have 0, 1, 2, 3, 4, 5. So you have 0, that your current node is index 0. Your 2 sum is 1 and 2. Okay. So this 2 sum is actually, one of them is 2i plus 1. And 2i plus 2. I equals 0, so 2i plus 1 is 1. 2i plus 2 is 2. So now let's look at 1. 1's left sum and right sum is 2 times 1 plus 1 is 3. 2 times 1 plus 2 is 4. Okay? And then 2's left sum and right sum is 2 times 2 plus 1 is 5. 2 times 2 plus 2 is 6. So your right sum is 2i plus 1, left sum is 2i plus 1. Is that okay?
Yeah.
Okay, so these are used to calculate your sum's location. Your sum is 2i plus 1 for left, 2i plus 2 for right. Now parent, you want to find your parent. So one's parent is 0, 2's parent is also 0. So parent's number is I minus 1 divided by 2, taking floor number. So it actually is I minus 1 divided by 2, and this whole thing taking integer, that's a floor number. Is that okay so far?
Yeah.
Quantize it with I minus 1 divided by 2. So when you have a 1 minus 1 divided by 2 is 0, so you get 0. 2 minus 1 is 1, 1 divided by 2 is 0. Okay, so both of them, parents is 0. You need to remember how to find the parent and son, okay, inside here. And parent and son is the way you find the element that you want to do promotion or demotion. Is that okay so far?
Yeah.
Okay. Okay, so this mean heap, mixed heap. Now, let's assume that your data coming is 1, 3, 6, 5, 9, 8. So 1 here, 3 here, 6 here, 5, 9, 8. Okay, so okay. So next one is the add and ship up. Add, you will add to the next location that's available. Okay. So the next location available right now, let's assume that you have actually let's do 1, 2, 3, 4, 5. So index 0, 1, 2, 3, 4. So the next location you put data in is where your size is. You currently have 5 data. Next location you put data still be the size of your, it's the same as your array list. Is that okay so far?
Yeah.
And then once you put the data over there, you do find its parent for promotion to ship out. Okay, so let's look at this algorithm. So you add the data of X, you put it there, you put it into the size location, array heap minus 1 location, right? You put into there, that's the data that you have, and you start to do ship up. Okay, so ship up, you start to use the array heap the size minus 1. Okay, and then while P not equal 0, so P is the current location. You find your parents and you compare your parents and your current location's data. If current location data is actually bigger than your parent, then stop, because you no longer need to swap. If not, then you swap the data of your current location and your parent, and then you set your current location to your parent after you swap. And then you continue that until your P go to the 0, and then you no longer need to swap. Is that okay so far?
Yeah. Yep.
Okay, try to understand it. Okay, this is the way we do add. Remove, you will check if it's empty. Empty, you will get it empty. Otherwise, you will take out the 0 location, right? 0 location is the smallest one in min heap. Then you will get the data at the last location, because you are going to, you get this one and you are going to put this one into the 0 location and do demotion, do ship down. Okay? Is that okay?
Yeah.
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 You take the last data, put into the top of the heap, and then do demotion. Now let's look at the demotion algorithm. So demotion algorithm, you will P starting with the equal 0, and then you get a size, and then your P times P 2 times P plus 1, that your sum location need to be less than the size. Okay, if you greater than the size, then you are done because you do not need to continue to go down. Then you find your left child and right child and see which child is a smaller number and then swap with it. Is that okay? You compare. So that's so you take out this 8, you put it on here, right? And then you compare your left child and right child, see who is the smallest. So 3 is smallest, so you actually swap your 3 and 8. And you put your current location down to your left child, the smaller one. And then this is smaller one compared with the left child or right child, see who is the smallest. So 5 is the smallest, so you swap 5 and 8, so it becomes like this. And then you move your current node to this, and then you try to see the next one, but the next one already greater than the size. There's no child under this node. This condition is say no child. Is okay?
Yeah.
Yeah.
When 2 times P plus 1 greater than size, then there's no child. Greater equal to size, there's no child. So less than size means there's still a child, you need to do demotion. Swap and demotion, okay? So in a way, this ship up and ship down both are swap based, okay? And it's operation on the array, so we call it array heap. So far, okay?
Yeah.
Array heap is very useful. Array heap implementation is easy, it's just an array. And it's working like a binary tree, so it also has a binary tree benefit. For Jiang, what is the binary tree benefit compared to array?
Binary tree what?
Binary tree's benefit, advantage.
I think it's like you can like access data faster.
How fast it is?
I think it's login.
Yeah, it's a log n time. So if you look at the array, you try to search using the linear search, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So on the average, it's order of n divided by 2 times, right? If this one you actually put into the tree structure, then the search time is becoming log n time. It's way reduced. Is that okay so far? Hello?
Yeah.
So in a way, array heap is a heap. So the advantage of the easy access using the array index still available. And access time is log n time. So it also has the access time like binary tree. So that's the advantage of this array heap. So array heap to implement the set map, okay, is very, very useful. Okay, so array heap can be used for quadratic queue. It can also be used for set and map that we are going to cover next week, okay? Very, very powerful data structure. Okay? So min heap. Okay, so insertion time is log n time. Deletion time is also log n time. Log n time means that you do promotion or demotion at most is actually log n. Okay, you just put the data into the last element. Okay, or you take the data from the 0 location. But you still need to do ship up and ship down. So those kind of ship up and ship down time is actually order log n time. Okay, access time is order 1 because you just take directly from the top. And implementation is also is memory. It's also array, so actually very saving memories. Okay. So max heap is opposite operation. Okay, so we don't cover max heap. So this is min heap. Okay, this I think this things that no, we're going to cover this later. Okay. Now let's look at how to use a heap. Okay. Okay, let's copy this one directly. Okay. Okay, so this one is a heap. It has an array of heap and size and minimum size. So maximum size is used to set up, for example, you actually initially you do 127. So they are 2 to the power 7 level. Okay, there will be 7 levels. You can set up the data like that, okay? That's a capacity. And then you do, there's a function to calculate the parents. There's a function to calculate the right child and left child. Okay, we talked about it already. And you can check if the node is a deep node or not, okay? And then there's a swap function to do swap. Okay, and then there's heapify. Okay, heapify means ship down, okay? Heapify is ship down. And then the insert function is a ship up, okay? And then there's a print function and a remove function. So right here, you actually create a min heap of 15 data. Usually this one, you use a 2 to the power n minus 1, okay? Because it actually is the maximum capacity of a certain level. And you insert several data and then you print it, okay? That's it. Okay, so this one like that. Anyway, this min heap and max heap just a idea of what? Of using the heap. Okay. One way you must know is that, okay, let's go back to our first things that we covered. One way you need to know about is here you do have priority queue in Java. Okay, so Java's priority queue is actually using array heap. Is that okay so far?
Yeah.
So the idea is that actually your queue your DQ, your list, your step, they are all implemented by array only, still under the array, okay? Even though they are different kind of abstract data type, they are just still some array, okay? Is that okay so far?
Yeah.
Okay. So next time we'll talk about hash function, and we'll talk about priority queue, heap, hash function, and go to set and map. Okay, that's the next time. Now, let's start the heap, min heap, max heap right here. Okay, this one I'm going to cover the problem. I'm sorry then. Okay. Anyway, let's directly go to the user code training side. Get one more problem from here, okay? So today we are going to finish this one broken back necklace. So we go into the 1.3 complete search. So complete search means that you go to the whole solution space, okay? So we talked about the solution space before. Now we go to work on the first problem, milking cow. Okay, this one called milk 2. Let's look on this problem. Okay, so this is milking cow problem. It's called milk 2, okay? The farmers rise 5 a.m. in the morning and head for the barn to milk 3 cows. So first farmer begin milking his cow at the time 300 major second after 5 a.m. So they kind of starting from measure in seconds. Okay, so first one is 300, okay, and the time 1000. So it's measured in seconds. So 300 seconds is 1 time, and then n is 1000. Okay, so this is the time that he begin milking his cow, and then the next farmers come at 700 and end at 1200. So these two has some sort of overlap. Okay, so the longest time no milking is done between the beginning and the end of the milking is 300 seconds. You will write a program that will examine the beginning and ending times of the N farmers milking N cow and compute. So the longer the interval, least cow was milked. You report in the longest time interval, at least 1 cow was milked. And the longest interval that no cow was milked. Okay. So you have milking period like this. Okay, that's assume you start from here. You end from here. So this period of time, you do have some cow bean milk. This period of time, you do have some cow that you actually do have milk. So this period of time, you don't have cow milking. So they want you to pick out the largest time that had at least one cow being milked. And the largest time maybe this one that has the longest time that no cow being milked. Okay? Is that okay so far?
Yep.
So they do give you three. Three means the three line you need to read in. And then they started from 300 and then whatever, and then they have intervals. So let's look at this case. This one is starting from 0, you go to 300 and then 1000 and then 1200, 700 to 1200 and then 1500 to 2100. So now here is the buy time of 300. This one is 300 to 1200. This is 900 of milking time. Here you have a buy time of 300. Here you have milking time of 600. So your return maximum milking time is 900. Buy time is 300. Okay. Now, how to solve this problem? Harrison, how to solve this problem?
You like loop through it all, and then you like set like max values between
What is the max value?
like the current max, and you compare it to like the previous max.
This cannot solve the problem. Is you just talk about finding the maximum or minimum. That's actually talking about nothing. You may have milking period that actually is overlapping.
Wait, can I pull up the code where I did it? I
Hmm?
did it. Can I open the code I did for this one? I did it
I
one.
don't need that.
Okay.
I need you to talk about it.
I think it's like you set like I think like how I did it was I set like start and end,
Yeah.
and then I compare like and then I compared the start to end in like um in like a loop.
What kind of loop?
I kind of forgot how I did it.
You forget that how you did it,
Yeah.
then I don't need to look at your code or your drafting. You know why? If
What?
this algorithm is invented by yourself or you know how to do it, you should be able to talk about it. It is impossible that you forget the answer, how to do it, right? If you know it, you should be able to talk about it. How about Jiang? Do you know how to solve this one?
I actually didn't solve this one, but I think I can solve it by using the first number S, I mean the E, and checking if it's like if the second input's starting time is like smaller than the first input's ending time, and um check if the second input's ending time is longer than the first input's ending time, and so on until like the conditions returns false.
Okay. Kind of, you talk about the beginning times. Okay, that's good. From what you say, I cannot fully understand your approach, but I kind of knowing that you are thinking about something. Okay, that's not bad. How about Kingston? Kingston, can you talk about how to solve this problem?
Um, can you have like an array of 701 elements, and then you just for each interval you just put like a number in there and you add one, so you know how many cows are being milked at each time frame, and you just loop
Okay.
through it.
Okay, so one stupid way to do it, one stupid way can solve the problem is this one. You do see the maximum number 2100, so that's actually declare an array of 2100, right? So you say that actually 0 to 300, 300 to 1000, so that's actually mark this portion to be occupied. And then 700 to 1200, okay, let's actually mark this one to be occupied. And then actually mark 1500 to 2100 to mark this one to be occupied. And then you actually see which is the longest run that you have, right? And the longest no run that you have. You should be able to solve the problem, right? Is that okay?
Yeah.
But this one has one problem that you may use a lot of memory, because if this one is 1 million, you have to use a 1 million location that actually may waste memory. And also it's not efficient, because when you check the longest run, you actually need to go each individual timestamp to solve the problem. Okay? Then that's not a good way to do it. Okay, and then the one that John's talk about, the time arrival, is a good idea, okay? Now we need to look at the time of arrival. We need to use the time of arrival as a approach to solve this problem. So let's assume that your time of arrival is 300 to 1000, and then 700 to 1200, and then 1500 to 2100. Okay? So if you can do this, if these two have overlap, can you do merge? So if you have two data, it may be not overlapping, or maybe overlapping, or maybe this one contained by the other, right? Is that okay?
Yeah.
And then these two you can actually merge to one. So after you do merging, it will become these, and these. Then to find the maximum runtime is very easy. Actually, you actually see the beginning and end time of these two, and then you compare which one has the longest time, right?
Yeah.
Harrison, is that okay so far?
Yeah.
Now, how to find the maximum byte time? You merge everything together, so you have all of the interval that actually is on. Now I want to see the uptime. How can I see which one has the longest uptime? Anyone have an idea? Hello? Hello? Anyone has an idea?
Can you repeat the question?
My question is how to find the maximum byte time, the one that no one is milking. You do have the information of this one is a milking period from 300 to 1200. We merged for the from 300 to 1000 and 700 to 1200, and now it merged to 300 to 1200, one interval only. And then 1500 to 2100, that's another interval. Now from these two data, how can I find the maximum byte times?
Dr. Chow,
Yeah,
can't you just do like the when might subtract the from like the next startup time from the previous ending time, and you loop through it, and then
yeah,
you find the
yeah, that's
maximum
it.
of this?
So basically the byte time is the, okay, let's actually look at this one. It's very simple. You do have an interval of 300 to 1200. You do have 1500 to 2100. That's actually assuming that this starting time is 0. Okay. So this is actually your interval that you have for the milking time. Now, using 0, so this one is starting time, this is ending time, this is starting time, this is ending time. So you use the 0 as your starting time. This is starting time as your ending time. That's one interval of the byte time. Using this ending time as the starting time, this starting time as the ending time. This is another interval. So find the maximum of this. This actually is the byte times interval. So still loop through here. You starting using the 0 and this starting first E, you find the first block. Using this one's ending time and this one's starting time, you find the second one. Is that okay so far?
Yeah.
Yeah.
Okay. Okay, this problem, I'm not going to solve it. I want you to work on it by yourself, okay? I already explained the algorithm. I hope you can understand it and implement it by yourself using a list. So key point is that how you handle the overlap problems. Now you would solve the first part, the milking time part, using the so-called overlap. Okay, overlap. Second time is that you use the starting time, ending time, okay, to create the byte times. Okay, so from one already solved interval to another already solved interval. Okay, then you should be able to solve the problem. Okay, So this one, I'm not going to implement it. I want you to work on it by yourself, okay? Is that okay so far?
Yeah.
But I think the algorithm, I already explained it very clearly. Okay, so coding. Coding is very simple. You can use whatever code generator now to help you. Idea is more important. So here we want you to discuss. I don't need to see your code, right? I don't. Based on what you talk about, I know whether you know it or not. This is interview. So when you go to an interview or you go to a competition or something, sometimes they do have interview, or you apply for college, they do have interview. And the interview, they may ask some question like what I'm asking right now. Okay, especially in the interview, job interview, they will ask similar problems. Why you do this, why you do that? And do you know how to solve the problem? But you need to discuss how you solve it, okay? You cannot say, oh, let me give you the code. Who care about your code? Nobody care about your code. Maybe you copy the code from somewhere else. How can I know? And I don't need to know about whether it's your code or other people's code. I don't really care. I care you know it or you don't know it. Okay? Is that okay?
Yeah.
Yeah.
If you don't understand it, you cannot say about it. You cannot. If you do understand it, you should be able to talk about it. There's no way that you talk about it like, oh, I forget it. I forget how I did it. That's not the way you do coding, okay? You do coding and you talk about people, I understand this problem, but I forget how to do it. That's impossible, okay? That's totally impossible. This problem, I may solve it 10 years ago. But right now, if I pick up this problem, I still can talk about it. That's algorithm. That's the way you remember problems. Okay? Is that okay?
Yeah.
You must exactly understand how to solve the problem and how you get to the answer. Okay? If you really go through it, it is your own idea, it's your own algorithm. Okay? If you never, you just look at other people's code, then you are not able to solve it. That's not your code. Okay? That's not your code. That's other people's code. So we do train you to solo learn, to learn the language, and then coding back. Level 1, 2, 3, okay? Recursion, function, math. And then we go to user code, and then you study from bronze, silver, gold, platinum. So each level has more difficult problems. You really need to practice more in the level. So you really need to exercise a lot of problem in a lot of level before you can move on to the next level. Okay. Not because that you want the title, but because you really want to solve all kinds of problems. If you try to avoid, even though you jump very fast, but later you may regret because some problem you never solved it before. Okay? So do work hard, work on those problems by yourself, making sure you understand it, okay? Is that okay?
Yeah.
This portion, if you come to this lecture for 2,000 times, I guarantee you it's not going to help you. If you work on it by yourself only one time, you will fully understand it. Okay? So the key point is that you must do coding by yourself, must go through the process of thinking by yourself. Okay? Don't rely on other things a lot, because you rely on other people to talk about it. That's too late already. That actually problem already been solved. You waste that problem. Okay? Okay, today is up to here. Okay, good night and bye bye.
Thank you. Bye
Bye-bye.
bye.
Bye.
Thanks.
Thank you.